Welcome to solverfy.
For this problem on the topic of oscillators, we are told that a bungee jumper jumps from a bridge, and when reaching the lowest point, he oscillates up and down 8 times in 43 seconds. We know the mass of the bungee jumper to be 65 kg, and we know that he comes to rest 25 meters below the level of the bridge. We want to estimate the spring stiffness constant as well as the unstretched length of this bungee cord. Now, the period of the jumper's motion, t, is the time taken, 43 seconds, for the 8 cycles at the bottom of the motion. And so the period of oscillation is 5.375 seconds. Now, the spring constant can be found from the period and the jumper's mass, since we know that the period t is equal to 2 pi times the square root of m over k, which means that the effective spring constant of the bungee cord, k, is equal to 4 pi squared times the mass of the bungee jumper, m, divided by the square of the period, t squared. So putting in our values, we get this to be 4 pi squared times the mass of the bungee jumper, 65 kg, times the period, 5.375 seconds squared. This gives us the spring constant of the bungee cable to be 88.821, or to 3 significant figures, 88.8 newtons per meter. So we now have the effective spring constant of this bungee cord. Now, the stretch of the bungee cord needs to provide a force equal to the weight of the jumper when he is at the equilibrium point. So at this point, K delta X must equal to mg. And so this means that the extension of the bungee cord, delta X, is equal to mg over K. And so this is 65 kg times the acceleration due to gravity, 9.8 meters per square second, divided by the spring constant, 88.821 newtons per meter, which gives us an extension of the bungee cord of 7.17 meters. And since we know he comes to rest 25 meters below the level of the bridge, the length of the unstretched bungee cord X must be this distance, 25 meters, minus the extension, 7.17 meters, which means the bungee cord has an unstretched length of 17.8 meters.